first trial.
Langgol. 20. Time's up. Pila kang goal? 20. Taps. Sige. Ibut kira tanan niyo eh. Iot gila. So dia. Koto. Beli ka nangol. Tara gyapon. Tara. Gumoy boto.
Second trial. Third trial.
Problem: an object is launched by a projectile launcher from a height with an angle and travel the total distancia at total given time. Find the initial velocity v, initial velocity in x fix, and yv, maximum height in the time traveled to reach its maximum height.
So here is our first trial, which is the angle of 20 degrees. So now we have the given data, which is the angle of 20 degrees, the time, which is the 0.8 seconds, the range, which is the 1.74 meters, the height, which is the 0.155 meters, and then the acceleration due to gravity is negative 9.8 meter per second squared. So now we can calculate the initial horizontal velocity, the initial velocity, the initial vertical velocity, time and maximum height, and lastly the maximum height. First, we're going to solve the initial velocity. So we'll proceed in getting the initial horizontal velocity. So first, the formula for initial horizontal velocity is Vox equals to range over time. So our range is 1.74 meters over our time, which is the 0.8 seconds. So the answer is 2.175 meter per second. So that's our initial horizontal velocity. So now we can get the initial velocity. So the formula for initial velocity is Vox equals to VO times cos theta. To get the initial velocity, we will substitute the gathered data to get the unknown, which is the initial velocity. So our Vox is 2.175 meter per second. We will divide it by the cos theta, which is the cos 20 degrees. So our initial velocity is 2.31459. And then we will proceed in getting the initial vertical velocity. The formula for initial vertical velocity is Voy equals to VO times sine theta. We will substitute the gathered data. We have the VO and the sine theta. So to get the initial vertical velocity, we will going to multiply the initial velocity, which is the 2.31459, to our sine theta, which is the sine 20 degrees. So our initial vertical velocity is 0.79. So now we will proceed in getting the time in maximum height. The formula for time in maximum height is T max equals to time over 2. So our time, which is the 0.8 divided by 2, so our time in maximum height is 0.4 seconds. So lastly, we will get the maximum height. So the formula for maximum height is final velocity squared equals initial vertical velocity squared plus 2 times acceleration due to gravity times maximum height minus height. So our final velocity is 0, and then the initial vertical velocity is 0.79 meter per second. and then our maximum height, which is the unknown, and our height is 0.155 meter. Then solve the unknown, which is the maximum height. We'll do substitute 0 equals 0.79 meter per second, then squared, plus 2 times negative 9.8 meter per second squared, times maximum height minus 0.155 meter. And then 0 equals 0.6241 meter squared second squared, plus 3.038 meter squared over second squared, minus 19.6 meter per second squared maximum height. So to get the maximum height, we'll transpose the maximum height to the left, so it will be positive. So 9.6 meter per second squared maximum height equals 0.6241 meter squared over second squared, plus 3.038 meters squared second squared. So we will divide it both sides by 19.6 meter per second squared. So our maximum height is 0.186842 meters.
And now, let's proceed to the second trial, which is we have the angle of 40 degrees. So let's go back to the problem. An object is launched by a projectile launcher at an angle of 40 degrees with a height of 0.18 meters and travel the distance of a total distance of 5.08 meters with a total time of 1.85 seconds. And now we need to find the initial velocity at x, the initial velocity at y, the maximum height, and the time traveled as it reaches the maximum height. First, we need to find the initial velocity. So we need to, since we have the formula of the initial velocity at x and initial velocity at y, which is v, or initial velocity at x is equal to initial velocity times cosine theta, and the second formula of initial velocity at y is equal to initial velocity times sine theta. Since we don't have any, or we don't have yet the initial velocity, we need to use some alternatives. So we have the formula of initial velocity at x is equal to delta x, or change in x, all over the total time, so substitute the given values. So we have initial velocity at x is equal to 5.08 meters over 1.85 seconds. We have the initial velocity at x is equal to 2.75 meter per second. So we have the initial velocity at x. To find the initial velocity, we need to substitute the initial velocity at x to our formula, which is v sub ox, or initial velocity at x is equal to initial velocity times cosine theta. So we have the initial velocity at x is 2.75 meter per second, and our initial velocity is unknown, and our theta is 40. So 2.75 meter per second is equal to initial velocity times cosine 40 degrees. To find the initial velocity, we have initial velocity is equal to initial velocity at x all over cosine 40 degrees. So we have initial velocity is equal to 2.75 meter per second over cosine 40 degrees. The result is initial velocity is equal to 3.59 meter per second. So we have now the initial velocity, which is 3.59 meter per second. Now, we need to find the initial velocity at y. So since we already have the initial velocity, it is easy for us to find the initial velocity at y. So the formula is v sub oy, or initial velocity at y, is equal to initial velocity times sine 40 degrees. So VOY, or V sub y, is equal to 3.59 meter per second, our initial velocity, times sine 40 degrees. So the result is V sub OY is equal to 2.31 meter per second. So our initial velocity at y is equal to 2.31 meter per second. To find the time of the object as it reaches to its maximum height we have Mikael, Joaquin, Jinsis to help us solve and find the time and the maximum height of the object. Mikael?
Good day everyone. So since we already have the total time traveled by the object until it reaches to the ground, which is equal to 1.85 seconds, to find the time traveled by the ball as it reaches its maximum height, it is just we need to divide it by 2. So we just learned it from our lesson that the time of an object it is reaches its maximum height is half of the total time. So we have the T max equals to time over 2, and time max is, our time is 1.85 seconds divided by 2. So in result is equals to 0.925 seconds. Thus, the time traveled by the ball as it reaches its maximum height is 0.925 seconds. And now we just need to find the maximum height traveled by the object. So we have velocity O squared equals velocity OY squared plus 2a delta y. And also we have velocity O squared equals velocity y squared plus 2ay, open parenthesis, our y final minus y initial. Since the initial height is 0.18 meter and the initial velocity at y is 2.31 meter per second. So we have to solve it by using the formula above. So we have our velocity squared is 0 and equals to velocity OY squared 2.31 meter per second raised to 2 plus 2 from the given, and our AY is negative 9.8 meter per second squared. So we have our final minus y initial 0.18 meter. So let's continue. 0 equals our velocity OY squared is 2.31 meter per second squared raised to 2, so we need to times by itself. So we have 5.34 meters second squared plus 2 times our AY, so we have negative 19.6 meter per second squared. So we have our y final minus 0.18. We need to copy. Let's continue. So we have 0 equals 5.34 meter squared second squared plus negative 19.6 meter second squared, and our y final plus, in result we have 3.53 meters squared second squared for our y initial. Let's continue. So we have 0 equals 8.87 meters squared second squared because we have to add our velocity OY squared and our Y initial. So we have 8.87 meters squared second squared plus our AY is negative 19.6 meter per second squared. Y final. We need to transfer the result of our velocity OY squared plus Y initial to the other side across the equal sign. We have negative 8.87 meter squared second squared equals negative 19.16 meter second squared, and Y final. We need to divide both sides with negative 19.6 meters second squared. So we have Y final is equal to 0.45 meter. This for the maximum height reached by the object is 0.45 meter.
Let's have a recap. We have the initial velocity at x, which is equal to 2.75 meter per second. Our initial velocity, which is 3.59 meter per second. Our initial velocity at y is equal to 2.31 meter per second. Our time of the object as it reaches its maximum height, which is equal to 0.925 seconds, and our maximum height reached by our object is equal to 0.45 meters.
In the third trial, we have the given data, which is the angle that is equal to 50 degrees, the time which is 1.05 seconds, range which is 3.13 meter, height which is 0.2 meter, and lastly, the acceleration due to gravity is negative 9.8 meter per second squared. So we can now calculate the initial horizontal velocity, initial vertical velocity, time and maximum height, and the maximum height. So first, we're going to solve for the initial velocity, but we don't have the data to gather it, so we will proceed in getting the initial horizontal velocity. So the formula for the initial horizontal velocity is equal to range over time. So our range is 3.13 meter, then divided by our time, which is 1.05 seconds. So our initial horizontal velocity is 2.98 meter per second. So next, we get the initial velocity. So the formula for the initial velocity is initial horizontal velocity is equal to the initial velocity times cos theta. To get the initial velocity, we will substitute the gathered data to get our unknown, which is initial velocity. So our initial horizontal velocity is 2.98 meter per second. We will divide it by the cos theta, which is cos 50 degrees. So our initial velocity is 4.64 meter per second. Then we will proceed in getting the initial vertical velocity. So the formula is initial vertical velocity is equal to initial velocity times sine theta. We will substitute the data we have, the initial velocity and sine theta. So to get the initial vertical velocity, we will going to multiply the initial velocity, which is 4.64 meter per second, to our sine theta, which is sine 50 degree. Using the calculator, we get the initial vertical velocity, which is 3.55 meter per second. So now, we will proceed in getting the time and maximum height. So the formula in time and maximum height is equal to t over 2. So our time is 1.05 seconds divided by 2. So our time and maximum height is 0.525 seconds. So lastly, we will get the maximum height. So the formula is final velocity squared is equal to the initial vertical velocity squared plus 2 multiplied by the acceleration due to gravity times maximum height minus height. So the final velocity squared, which is 0, equals to the initial vertical velocity squared, which is 3.55 meter per second squared, plus 2 times acceleration due to gravity, which is negative 9.8 meter per second squared, times the maximum height, which is the unknown, minus height, which is 0.2 meter. Then, transpose the unknown, which is the maximum height, to the left side. So, it will become 19.6 meter per second squared times the maximum height equals to the 12.6 meters squared per second squared plus 3.92 meters squared per second squared. So, to get the maximum height, we will divide both sides by 19.6 meter per second squared. So, our maximum height is equal to 0.84 meter.